In this video, we'll go over the second page of the Propositional Logic Extra Practice. So in this page, we start off with two proofs that already have the statements filled out. We just need to fill out the reasons and the steps. So we're not necessarily doing it by scratch. So the main thing we want to focus on is essentially the difference between the two lines and figuring out what rule would cause that pattern change. So if we notice in the first line to the second line, that piece in the back of the or and the not P and not Q stays exactly the same in the second line. So we didn't manipulate that at all. And the not in the front also did not get manipulated at all as well. So the thing that gets manipulated is essentially that first piece after the not. The not P implies Q suddenly becomes not P or Q. So if we look over at our rules and we try to look for one that deals with an implies going to an or, that's going to be our implication rule. So we're going to have implication on line 1 that gave us that change. It takes something implies something else. It negates the hypothesis of the implies and leaves the conclusion alone. So since we started with not P, we end up with the not P, and the implies becomes an or. So that would be our rule that gave us line 2. From line 2 to line 3, we want to look at some differences. So the or in the middle does not change, so that doesn't get changed at all. And then the piece in the back as well does not get changed at all either. So again, the main thing we're looking at is this piece in the front. So the not in the front stays the same. The or Q is the same. The only thing that's different is we have this not P suddenly just becoming a regular old P. So if we look over at our rules and we look for something that deals with essentially multiple negations and getting rid of negations, if you will, that's going to be our double negation rule. So we'll have a double negation on line 2. That gives us line 3. From line 3 to line 4, what is the difference? Again, that back piece still hasn't been affected at all. That just stayed the same. But what's happened now is that not that was originally in the front seems to kind of have been pushed through, if you will. That P or Q suddenly becomes not P and not Q. So if we look over at our rules and look for something that changes an or to an and moves around negations, the only thing that does that for us is De Morgan's laws. That's the only thing that deals with changing an and to an or in general even. So even just the fact that an and changed to an or changed to an and should lead you to a De Morgan's law. So this would mean this was De Morgan's law on line 3, which gave us line 4. And now we need to look and see what gives us line 5. So line 5 is kind of very different because we kind of seem to have lost half of it. But if we look at what we have in line 4, we have not P and not Q. And then we have an or symbol. And then we have not P and not Q. Notice that those two things are exactly the same and they're just joined together with an or. So from the last page, we got these kind of two new rules that tells us that we could essentially always go between something and itself to just the something, or even something or itself to just itself. And we're calling this just for the sake of practice. This is not their official names. We're calling them self-addition or self-or. So what we can actually use here, since those two things are exactly the same, this would actually be a case of that self-or situation. Sorry, on line 4, not on line 5. Because essentially we have the same thing twice combined together with an or. So if we have the format of P or P, we can conclude P, which is exactly what we're doing here. Of course, that P is more complicated. That essentially the P in the pattern that we're looking at turns into the not P and not Q. But since we have that pattern of something or itself, we can conclude just that something by itself. So that would be how we complete that proof table. So the main thing for these is to just try to look for the patterns and look for the differences between the lines, and then take that kind of pattern, what signs have changed, what is being manipulated, are there negations being manipulated? Is an and turning into an or? Is an implied turning into an or? Are, two negations suddenly gone? That kind of thing. You want to try to look for these patterns and then go over to your rule and see what rule follows that pattern. So if we look at this next proof table, we start with P implies Q implies R. And the first thing we notice is the step to line 2, the Q implies R is still there, but the first implies turns into an or, and we pick up a negation in the front of the P. So what rule deals with changing an implies to an or? Implication. An implication also does negate that first, the hypothesis of the implies, which is the correct pattern here because the P went from positive, if you will, to being negated. So that would be an implication rule on line 1. From lines 2 to 3, what's the only thing that's changing? Well, that not P or in the front is staying exactly the same. And now what's being affected is actually that second original implies. And that implies is now becoming an or, and the hypothesis of the implies is being negated. So that's actually going to be another implication rule. So an implication rule on line 2. So now we've dealt with all of our implies. We don't have any implications left, so we might not be using an implication rule for a little bit. So from line 3 to line 4, what's happening? So notice that essentially all of the symbols, besides the parentheses, stay exactly the same. We start with a not P, we end with a not P. We have an or, we end with an or. We have a not Q, we end with a not Q. We have another or, we end with the or. We have an R, it ends with R. Like, none of that is changing. And so, the only thing that's changing is the placement of the parentheses. And the placement of the parentheses, if we go over to our rules, the only rule that deals with essentially moving parentheses is going to be our associativity rule. That's the only thing that moves the parentheses, but everything else stays the same. And notice in the associativity rule, that's essentially the only rule that has multiple ands or ors, but they all have to be the same thing. Notice the only one that deals with multiples is associativity and distributive. And distributive, they're different. So that should also be a big tip off here, is that it's going to be associativity over distributive rule, because all of those signs in the middle, they were all ors. For the distributive, one of them must have been an and. So in this case, this would have been associativity on line 3. Line 4 to line 5, notice the or R in the back stays exactly the same. And so the thing that's changing is the thing in the front, and essentially an or became an and. So our or symbol suddenly became an and symbol. Both of our statements are no longer negated, and the negation is now just out front. So if we go over to our rules, what's the only one that deals with switching an or to an and? Is De Morgan's. And remember that, of course, De Morgan's then also essentially pulls that negation out, is what we're doing. So we have De Morgan's law on line 4. From line 5 to line 6, we have an or becoming an implies symbol and a negation essentially going away, if you will. So what's the only rule that deals with implies changing to ors or vice versa? That's our implication rule. So does the implication rule follow in fullness here? Well, it does, because essentially what's happening here is we're starting with the quote-unquote not P or Q and turning it into P implies Q. So we're taking the negation away from the first piece and changing the or into an implies symbol, and that will give us the correct use of an implication. So this was an implication rule on line 5. So that's what gives us those reasons for that proof table. So the last piece here, to write a proof sequence, we're doing this one from scratch though. Note that we only have one given. It's the thing to the left of that double arrow. So if we draw our proof table, statement and reasons, first thing we do is we write down what we're given. And what I'd like you to do now is I'd like you to, if you haven't already tried this, I would like you to pause really quick and take a minute to look at your rules. So look at the rules on the side and see what could produce this P or Q that we're going to desire. So note that we have an or, but we have too many negations going on. Take a minute to try to look at some rules that might get us there. So, if we're looking at this and we're trying to get to P or R, and this is our given statements. Now, sometimes you can try rules and go down a rabbit hole and realize it's not the right way and then have to start over. So what I'm going to do is I'm just going to start looking at rules that I think I can use here. The one thing I notice is I have a negation out front of this kind of or statement. So I know that I could use De Morgan's law on that. I don't know if it's going to get me anywhere, but I could use it. So let's go ahead and use De Morgan's law. So we're going to bring that negation into both terms and change the sign. So we use De Morgan's on line 1. And I know that eventually I want a regular P, not one with negations on it, so I could change that one. I notice that I have not P, which could become regular P from double negation. Now here's where it gets a bit clever. So notice that we want an or statement. Now, or statements are very easy to create because of the addition inference rule. So whenever you want to end with an or, you really should be keeping that addition one in mind. You might not need it, but it's definitely one that's going to be helpful because if you can at least just get one of the two, you can always just add the other thing you need. So in this case, we have the regular P now, but we don't want that not Q. But notice that we have an and statement here. And we have a couple rules that deal with ands, and one of them in particular would be able to essentially get rid of that not Q. And that would be our simplification. So if we use simplification here, that would just leave us with P. So simplification on line 3. And then again, the nice thing about the addition rule is now that I have one of the two things I want in my final or statement, I can just tack on the other one. The addition rule is very nice. It's not used very often, but if you need to create or statements, it's very general. You can tack on anything you need. So we can actually finish out this proof by just tacking on an or with an addition rule on line 4. So when I was asking you to go over a few minutes ago and pause the video and look at the rules that could give you this, if you're looking for things that can give you an or statement, the things that should have jumped out to you should have been addition, implication, and De Morgan's. Those should really be the 3 that jump out to you. Notice that implication didn't help here at all because we didn't have an implies to start with, and we don't necessarily want to change to an implies because then we'd have to change back. And unless we can really manipulate the implies, there was nothing that was going to happen there. And we have no other rules to really manipulate implies very much, so that probably wouldn't help. But those would be the 3 to keep in mind, and then hopefully you would be able to see after you do some other rules, like you do the De Morgan's, you get the double negation out of the way, that maybe it starts to become a bit clearer that, oh, addition's probably going to be the one that gets me home here. So that's the end of page 2. If you would like to continue, there will be the 2 last videos on the last 2 pieces. Otherwise, let me know if you have any questions on this page.